It's possible to use data to write an exponential function. We use the base form f of t equals y naught, or y sub 0 times b to the t. So if we're writing an exponential function, perhaps we don't know what y0, the starting amount, is, or b, the base or the rate of change. So for example, in the year 2010, $1,000 was deposited in an account paying interest compounded annually. In 2015, there was $1,104.08 in the account. Write an exponential equation for this situation. So, using the form written above, the starting investment, or the starting amount, is y0. And in this case, that is $1,000. And that goes with time 0, or the starting time, which in this case is 2010. So that's the first part of this function. So we have f of t equals 1,000 times b to the t. And now we want to find out what the base b is after having the starting amount. So the other piece of information that we have is that in 2015 there was $1,104.08 in the account. So that means at time t equals 5, because the time between the starting time 2010 to the next time we have 2015 is 5 years. At t equals 5, we know that f of t is this amount. Okay, so we have that f of 5 is equal to 1,000 times b to the 5th, and we know that f of 5 is equal to $1,104.08. So now we solve this equation for b. So to do that, we can divide both sides by 1,000. If we do that, we get b to the 5th equals 1.10408. And now to solve for b, we want to multiply by 1/5 in the exponent, or take the 5th root of both sides. So, to multiply by 1/5 in the exponent, on the left side we would have b to the 5th to the 1/5 power, and then on the right side we would have 1.10408 to the 1/5 power. Calculating this, we get b to the 1st, or just b on the left side, equals 1.10408 to the 1/5 power is approximately, because there is some rounding, 1.02. So that means that our equation, f of t, for this situation is the starting amount 1,000 multiplied by b, which is 1.02, to the t. So this equation now could be used to calculate the amount in the account after 10 years or after 20 years. So if we wanted to find the amount in 2040, since that's 30 years past 2010, we'd plug in 30 for t. But we just need those two pieces of information in order to write this exponential function. So one starting year, and then some number of years later, the amount in the account.